G'day YouTube, warbles on a lot here. Sun's over the yardarm, therefore, thus and because, Happy New Year! And I think we'll have a New Year Mad Scientist video with a Woo Glass update. And what's a Woo Glass, do I hear you ask? Well, for those of you who've been paying attention to my scroll, for Christmas I was given an Admiral Fitzroy's Storm Glass. And they must have been the internet sensation this year for Christmas, because not only did my son get one, my mother got one, my daughter bought one for herself and gave the previous three to us. A friend of mine got given one as well. So they're out there. And I've watched a few videos on them. And it seems there are three basic, maybe four basic variations. One variation suggests that you've got to have absolutely pure alcohol and absolutely pure distilled water in a precise quantity in which to dissolve your saltpeter and sal ammoniac and your camphor. There's one variation on that which suggests that if you use 100 proof vodka, it's pre-mixed pure alcohol and pure water, because that's what vodka is. 100 proof, 50% alcohol. So instead of hunting around the chemist shop looking for pure alcohol and pure distilled water, you can use 100 proof vodka. Then we get into the issue that I had commented on in my earlier video, Science versus Woo, the Galileo thermometer and the Fitzroy storm glass, which is that the Fitzroy storm glasses, which are on sale and you can get them through the post, they're in a sealed glass ampule. So the only thing that solution can respond to is temperature, which in 1863 led somebody to write a learned paper to the Royal Society explaining that they are nothing but a thermoscope. Thermoscope meaning it shows the temperature changing, but it doesn't actually enumerate the degree to which the temperature has changed. However, the not so horribly ancient Book of Science and Construction that I'm in possession of, it suggests making a storm glass which has a cork stopper in a test tube, and a cork stopper in a test tube is not hermetically sealed. It's going to allow atmospheric pressure variations and perhaps even humidity changes to affect the liquid. And you could say that in particularly humid conditions, the solution may take up water from the atmosphere, and in particularly desiccated conditions, the solution may give up water to the atmosphere. So maybe it's necessary to have a less than hermetic seal on the liquid. That's not what Fitzroy said, but then again, he wanted stuff that could be posted through the mail to be delivered to the coastal stations. Macropodus macropode, one of my subscribers has gone Googling or Wikipediaing or whatever and come up with some other source of information which suggests capping the storm glass with a brass cap with a small hole, specifically to allow air to contact the solution. I'd be interested in trying that, because if you've got three variables, if you've got temperature and pressure and humidity for the juices to react to, that might have some kind of synergistic effect on what goes on in the glass. The other suggestion was a rubber diaphragm, which would exclude humidity changes from affecting the liquid, but it would permit barometric pressure changes to push the diaphragm up or down. And yeah, so there are a couple of other ways of doing it, and I'm pretty interested in the idea of the brass cap with a little hole in it. I might just have to do something about that. But what I have done so far, particularly since the 29th of December, is at 8 o'clock in the morning, I've written down barometric pressure and temperature. and sometimes relative humidity once I thought of doing that. And then I started writing in the cloud conditions, because on the 29th at 8 o'clock in the morning, when, according to my calendar record, we got down to 14 degrees Celsius outside overnight minimum, 8 o'clock in the morning, 22 degrees Celsius, 1010 millibar. There was a band from 8 inches to 8.5 inches high of crystals. Then there was a milky column below 6 inches, and it was clear liquid in between. And then, as the temperature progressively rose, the crystals in the band dissolved, and the height of the clear column, or shall we say the base of the clear column, over the top of white crystals, came slowly down and down and down the tube. Morning of the 30th, 1006.3 millibars, 22 degrees Celsius, 8.5 inches to 6 inches. It was clear liquid with little flakes and stars and things that looked like snowflakes in the otherwise clear liquid. And there was a flat layer of flakes floating on top, and gradually, progressively, as the temperature rose, independent of anything else like relative humidity, independent of air pressure, the height of the crystals in the column dropped lower and lower and lower. 14 degrees overnight minimum on the 29th, 17 degrees on the 30th, 20 degrees on New Year's Eve, 3 3/4 of an inch high column of crystals underneath clear liquid. This morning there was only 2.5 inches of clear liquid, which at midday was down to 1 3/4 inches of crystals underneath clear liquid, and the flange at the bottom has gone clear. Here we see the Galileo thermometer, we see the metric ruler, we see the top of the storm glass. We see how the storm glass liquid reaches up 8.5 inches. We see the 30-degree ball resting firmly on the top of the stack, indicating it's 32 degrees or above. And right down in there, we see the crystals. And we see the flange, the hollow flange full of solution, has gone clear, and the side of the storm glass closest to the enamel dish is presumably getting radiant heat from the dish, which is picking up radiant heat from the roof. So yeah, we've got 1 3/4 inches for the height of the crystals. There's very definitely no flakes of anything in the clear liquid, despite the fact that it says crystals at the top equals thunderstorms. And right now, pretty close to actual local apparent time midday, because this wristwatch is showing Eastern Daylight Saving Time, which is 1 hour in front of Eastern Standard Time. What I see on my horizon is cumulonimbus on the build. The forecast is for rain and thunderstorms. The storm glass says we're going to have clear weather. We shall see what we shall see. I will now try and put this video into time compression, and I might come back in, say, half an hour. Back again. Guess what? I lied. It's only 15 minutes later, but I thought I'd show you 34 degrees outside air temperature under the trees. We only got to 23 this morning. And so, in the best of nursing tradition, we will start doing hourly observations. On video, 43 degrees out here in the clearing, as it is on paper. Okay, and as you can see, 1007.9 millibars, 38% relative humidity, 33 degrees here inside the hut. And allowing for the fact that the Galileo thermometer and the storm glass are both vertically much closer to the ceiling than is the electric weather station, I'm going to go with 34 degrees. I'm going to say 2/8 cloud, because there are big clouds out there, but they're not here over me. And at the moment there's not too many of them on the upwind side. But what we have is some crystals of camphor dissolved in water and alcohol and 2 different kinds of salt, and the crystals are reaching 1.5 inches high in the column, while the flange is completely clear. No flakes in the column. And what do you know, only half an hour later, that's a lot bigger. That's vastly bigger. And that hasn't grown any smaller either. So quickly, let us go and examine the Wu glass, which clearly tells us we have to have crystals in the upper half to indicate the probability of thunderstorms. Whereas, as we can see, we're looking at barely an inch worth of crystals in the glass. Okay, back again. And here's what the sky looks like now. I would have to say 5/8 coverage of cloud. At 34% relative humidity and 1007.1 millibars. And 3/4 of an inch worth of crystals in the Wu glass, with no flakes in the clear fluid. And might I say that this has been conducted with the window open and the door open as well. G'day YouTube, here we are again, and would you look at that sky? We have thunderstorms across the entire eastern half of the sky, and the sea breeze means they're all going to come this way. And here you see the glass of Wu. So we will see what we will see as time goes by. Okay, there you go. And now you know what we can see is a really well developing thundering of the storm coming in towards here from the east. The electric weather station and the Galileo thermometer and the Woo glass, they say clear weather. But I don't think the Woo glass is worth a pinch of shit